Right, so the title of today's notes is Systems of Equations. And we're also going to talk about inequalities. We're going to talk about them together in the same lesson. Systems just means more than one line, right? The solution to a line is all the points on the line. Now we're going to graph two lines. Okay, and either, we have two scenarios going on when you have equal. Okay, either A, they have a solution, or B, there's no solution. Nice and high tech, right? You have an answer or you don't. Okay, but of course we can't leave it like that, right? So now we're going to talk a little bit more specifically about what that means. When you graph two lines, we talked about already that there are answers where they intersect. Okay, or two lines will have a solution. There are two lines that have a solution. They're considered, okay, vocabulary word, is consistent. So two lines that do not have a solution, what do you think they would be called? Inconsistent. Now, an inconsistent and consistent are the two things we're talking about now. If two lines are consistent, there's two things that they would look like. They would either A, look like just plain two lines that intersect. And if that's the case, then they have one solution. And they're called independent. I kind of think about it as, you know, they do intersect, but they kind of go their own ways. They're independent of each other. They're going to cross, but then they just keep going whichever way they were going to begin with. So you have one solution that's considered independent. Or, the other scenario is, and we talked about this already, what happens if you have two lines and they are the same line? How many answers do you think they have if they're the same line? They have many solutions, right? Okay, they have many solutions. And we're going to call them dependent. I think of it as, you know, you either cross and go your independent ways, that's scenario one, or you just are always together, scenario two, dependent, the same line. So those are your only options, consistent with one solution and independent, or consistent with many solutions being dependent. Move over to no solution. If you're no solution, you're considered inconsistent. If you're inconsistent, okay, then you have no solutions. What kind of lines do those look like? Perfect. No solution. That's because they are parallel lines. And we are talking about, guys, we're talking about lines that are equations. We're not talking about inequalities right now. We're only dealing with equations. Now then, take out your paper that we're going to take graphs on, and look at the sheet that's full. We'll start with problem number 1. That's where I'm going to start with you today. In my opinion, guys, the biggest mistakes you're going to make today on these problems is solving for y. Alright? That's where you're going to struggle. Graphing, I think you guys have pretty much mastered. Alright, so let's be careful when we solve for y. Start to solve the system by graphing. Let me ask you a question. Do you see these two equations? What are other ways that we could have solved these equations? Yes, we're solving by graphing right now. What are some other ways?
Plug in 3 minus x for y.
That's correct. It's called substitution, right? You write everything in terms of y and plug it in. Does anybody else remember things that we did? Okay.
Cancellation. You can make it toward
That's
y.
right. You cancel the x or cancel. It's called cancellation elimination. Okay, so there's other forms. A matrix will do it. Okay, your calculator will do it. Right? Lots of ways. Today we're solving by graphing. So everything you get is going to be this nice, pretty intersection because that's the kind of problems we're solving. But in real life, they always cross really pretty answers. No. All right. So you can kind of give you an idea of the answer, but this is one method of solving systems. Okay, if you want to use different colors for today, it might help, but let's start graphing line 1. I'll graph line 1 in black. Will you flip 1 like me? Okay, and I'm going to redo this so that it says y equals negative x plus 3. That's kind of the format you're used to seeing it in. Then I'm going to rewrite line 2. It'll show up. Here's line 2. And we're going to say 2y equals negative 6x plus 2. Divide everything by 2. Those are the 2 lines we're going to graph. Go ahead and graph them. They're equal. We don't have to worry about inequalities. We're going to do inequalities next. And I'm going to label my lines because, guys, I'm telling you, your mistake is going to be in your graphing, in your solving. So it's easier and faster if you know which line is which. So then my line 2. Thank you. See, that's exactly what I was saying. That's going to be where your mistake is. Thank you. That's not where they intersected earlier today. There we go. Where do they cross? What's the answer? What's the only thing that makes both true? What point is that? Negative 1, 4. Excellent. So, sorry. Negative 1, 4 is the answer. And if you look back at your notes, what does that consider? If it has a solution, is it consistent or inconsistent? Okay, so we know it's consistent. And now then, do we think that it's independent or dependent? They went their independent ways, right? That's how you can kind of remember it. So it's independent. I'm going kind of fast, guys, because this is just for review. This is Algebra 1, except for the vocabulary. We're going to skip number 2 and move to 3. Okay. Again, let's find out, solve the systems. Okay. Number 1, we're going to solve it, which is going to make us take y equals 1/5 x minus 2. Right? I just divided everything by 5. Go to line 2. This time I'm going to move my move my 3 over, and then divide everything by 5. Graph both lines. Now, please. I could even stop, really, except for the direction it said solved by graphing. What do I already know that's special about these 2 lines? They're parallel. And because there's an equal sign, right, then that means that, are they ever going to intersect? Are they ever going to be equal? No. Now, if they were less than or greater than, then that changes things. So here's one. Now graph the other one at 3/5. Guys, just estimate 3/5 would be between 0 and 1. Jump up 1 over 5. I'm using 2 different colors, but you know, whatever you can do to help you remember, you want to number the lines because you'll make a mistake, just like I did on number 1 already. It's easy to mess up. You have to be real careful. Okay, now they want us to classify them, right? So we're going to say to ourselves, all right, remember, they either have a solution or they don't. So since they don't, what are we going to call it? No solution. We call it no solution, and what do we use with this step? Inconsistent. no solution, and it's inconsistent. Everybody good? Okay, go to number 4. Last problem like this that are equal. We're going to move it. Bouncing around a little bit. Okay. This line here, number 1, is ready for us to graph. We don't have to do any work. Move to line 2 and solve for y. 3y equals negative 12x plus 21. Divide by 3, negative 4x plus 7. What are we automatically already noticing? They just fancied up the what? The exact same problem, didn't they? You can go back and look at your notes if you want, but what happens when you have the exact same problem? How many answers are there? Tons, because it's the same exact line, isn't it? Every point on one line makes the other true, doesn't it? Even though it looks fancy or different, it's the same line. Line 1, which is right here, okay, this line, and line 2 here, they're the same line. Okay? So, graph it if you want. It doesn't even matter which color. This would be line 1 and 2, right? Does it have an answer? Yes. So we're going to call it consistent. Is it dependent or independent? Remember, consistent, if you look back at your notes that we took, if we're consistent, we're either independent or dependent. Which one are we if we're the same line? Right. Okay, then we're going to have to write our answer kind of fancy, because is the answer all real numbers? How come no? Good. It's not every point. Does this point over here make it true? No. Does this point over here make it true? No. Only numbers on the line. Now, there are an infinite amount of answers that work, but not all numbers work. Okay, so the way you write it is we're going to use set builder. Right? It's actually very easy if you really think about it. So open up your set builder, and I want to tell myself, okay, all the points on the line work, right? Well, so make yourself an XY. That's a point, right? All the points such that, so there's your line, such that they're on the line. What's the name of the line? Y equals what? Negative 4x plus 7? Like this? Now, if you really think about that, it makes perfect sense. Stop and look at it. All the points on that line. Isn't that all the answers? Okay. Let's move on. Now then, we're going to switch gears completely and move to what you see is different. Inequalities. All right, so number 1. These are done a little different. Because in an inequality we shade, right? So the answer is the shaded region. Well, if you shade one and shade the other, where's the answer going to be? Say it again. Good job. Where you shaded twice. Or they're both shaded, right? So let's graph number 1. Again, solving for y, like I said, guys, that's going to be the biggest mistake, so be careful. Negative 2y greater than or equal to negative x minus 2. We're dividing by negative, so we have to flip the direction of the inequality. It was already a negative, so it turns positive. So positive 1/2 plus 1. That's tricky. Be careful. Now graph your second line. Y is less than or equal to negative x minus 1. And then graph both lines. Start with your first line. It is a solid line. In fact, they're both solid this time. which direction am I going to shade that line? Up, above, or down below? Down below. Jump down. Less than means jump down. If you have a pencil, or if you want to use different colors, I don't know how you want to do it. If you're using a pencil, you're going to shade really light both times, and then darker works. If you want to use different colors, then you're going to look for everything that's black and everything that's green for me. So down below would be this. Right now, that's my answers. But if I go and graph the second line, again, it's a solid line. Okay, and I want everybody to graph the line and just listen to me for a second. Graph the line. At this point, I'm going to pretend, listen to me, I'm going to pretend nothing is there but my green line. That's it. I'm ignoring everything else. In my mind, all I see is my green line. And the green line says, you want to shade what? Less than. So I'm going to look at this green line, I'm going to shade less than green. I'm going to pretend like nothing else is there. I'm going to take my green line and I'm just going to shade. And my answer is where? It's where I have green and black both, correct? Which if you want to use a pencil or a highlighter or whatever you want to use, but you have to darken so I can definitely tell what the answer section is. Okay, let me explain something. That section is what makes both of those lines 1 and 2 true. Right? Some of these points makes black, some of the points are green, but in there, green and black are true. That's why those points work. Okay, skip number 2 and move to 3. Oh, it's not number 2. For you guys, it's 6. Thank you. Skip 6, move to 7. Move to 7. Sorry, my paper is printed a little different. This is line 1. Solve it for y. You're dividing by negative. Flip the direction of the inequality and be careful. Check your line. Make sure it's right before you graph it. Make sure you did the math correct. For number 3, I'm sorry, I said 3. For line 2, okay, this line, in my opinion, if you're not sure what to do, make yourself a little think bubble and just, let's make it easier. Think y equals 2, right? Y equals 2 is just a line. So you're going to do the same thing, but you're going to graph y is less than 2. So you're going to go and make a dashed line and shade under. Try to graph it. Okay, so grab both and shade. And this is an approximation. 2 3's fit in, so you're going to know okay, it's between 2 and 3. So I'm right here somewhere. You go up 4 and over 3. It's a solid line. And it's a less than, so you're going to shade down. Go to your second one, go to y equals 2, and a dashed line again. Which direction are you going to shade, guys? Down. Okay, so I'm ignoring the black line that's already there, I'm just going to shade down. And my answer then is where I have green and black, or for you, whatever colors you're using, or pencil, wherever you shaded both. All the way up to the dashed. All the way to the black, all of it. Go all the way up, not just the axis. Go all the way to the dashed line. I have a question for you. You'll notice right here is a point where they intersect. Does that point of intersection make this line and this line true? Okay, y'all are saying no, and you're accurate. How come? Good. One's a dashed line. So I know that the dashed line, it doesn't even make this true. Okay? It's equal. If you're on the line, you're equal. And this doesn't say equal. This is less than. So the only way that it works on the line is if they're both equal to, if they're both solid lines. Excellent. All right, go to the next one. I believe it's number 7, 8. There's 3 lines. Not a big deal. Graph 2 and graph the 3rd. Okay, you're just going to graph all 3. You've got to be more careful. Graph the first one. X is greater than -2. So here's -2, dashed line. It means you want the region that makes all 3 true, instead of just 2. Greater than would be here, very lightly, because now we have all 3. Some kids don't go all the way to the dashed line, go all the way. Okay, now then, line 2. Line 2 says y is greater than 4/3 x. There's no y-intercept, so where do I start? I start at 0. Again, a dashed line. Which area do I shade? Y is greater than. Now, look at me, guys. Watch this. So currently, before you graph your 3rd line, it gets super, super messy. In your head, you should recognize that this is one line. Here's another line. And currently, this is the shaded region. Agree? Right now, that's the winner. If you're in that spot, you're an answer. But we're going to graph this last line. So I'm going to go to 2. There I am. And I'm at 2/3. You end up being a dashed line through here. Okay, which part is true? The part above the black line and the part below the black line. It says right here, less than, below. So your answer is this tiny little triangle in the middle. You see what it did? And if you think it's confusing, that's why I stopped you at the 2nd. Right? I stopped you and said, all right, what's true? And then by the time you get ready to graph that 3rd line, it kind of helps things out. All right, start the next one. You start the next one. What do you notice, just without even graphing? What's going on here, guys? They have the same what? Same slope. And at the first line, you should shade greater than. And the second line, we should shade which way? Same shade. Less than. So what's the problem here? No solution. There's no spot. They're both shaded. Is there any way then on any inequalities that parallel line Because the last time we graphed parallel equal signs, right, with equations, there was no solution to. Can you have parallel lines with inequalities that are true? Now, your ideas. Why? How could I change this problem to give me some true answers?
Y is greater than.
Correct. If the black line went down and the green line was shaded up, the answer would be right in the middle at the tunnel. You see what I mean? Okay. That last problem. You're going to have to give me a think session for a second. So put your pencils down and just listen. In the past, we've studied this. And let me ask you, if I told you to graph this line here, what shape would you tell me it would become?
Right.
A what? A V. Okay? It's the absolute value would be a V. Now, but the problem at hand is not that. It's this. What's the difference in the absolute value here and the absolute value there? There's something very different.
There is no Y.
Good. The second problem isn't going to give me a V. It's just x's. Do you see the difference? So in here, every time x changes, y changes, and I get this V. It's different. This only has an x. This is what we did in our last unit test, correct? We have to see what two answers work. Some of you can just look at it. 1 works and -6 works. Okay, -5, I'm sorry. But if you don't see it, we say x plus 2, and I'm going to move it to over here. So this problem is x plus 2 is less than or equal to 3, and x plus 2 is greater than or equal to -3. Remember, two different things. It's not going to create a V. It's going to create two different what? What direction are they going to go? You're right, lines. Good. We're going to go vertical. An x equals line, vertical line. So here x is less than or equal to 1. X is greater than or equal to -5. Graph those two lines. They're solid. And on one we have less than, and the other we have greater than. So where am I going to actually shade? Right down the middle. Be careful, go all the way. Some kids are forgetting to go all the way over to the actual line. Past the axis, all the way to the line. Okay? Now graph line 2. Divide everything by -2. It's going to flip the direction of the inequality. And you're going to, right now, the answer is right down the middle. So when you graph this line, you've got to decide, our answer is going to be above the line down the middle or below the line down the middle. It's less than, so below. So graph the line. Shade right down the middle. Solid line.
Good afternoon, TMHS. As you know, voting will take.
Alright, so less than means gray, shade below. Right, so I'm looking for where green and black is shaded. So it's, don't forget to go all the way over and all the way up. Okay, and that's it for today.